Okay. Good afternoon, everyone. So yesterday's class, we have started with the forest fire susceptibility risk modeling and management, a geospatial approach. So, as in your forestry paper, we have following topics where in your first unit we have discussed various forest ecology, what kind of different forest ecologies are there, and then we have also studies different satellite sensors and their use in the forestry, different kinds of data sets which are being used for different kinds of forest applications. And then we have also studied the individual data wise role of different types of satellite data sets, GIS, GPS, into the different kinds of forestry applications. Then we have also gone through the different kinds of forest management strategies and how we can go for the sustainable forest management related things. Now we have different types of forest disasters which are there, and how do we go for the different types of susceptibility modeling, risk modeling and management using these geospatial approach. So first types of hazard, or you can say disaster or damage into the forest activities, is because of the forest fires, especially in the Himalayan areas where we have lot many losses of forest. So in our previous lecture we have try to cover what is forest fire, how many factors are there which are influencing or which are leading to these kind of forest fire activities, where we have studied these factors like or we have categorized these factors into four classes, which includes topographical, climate and accessibility to various things, and then fuel type and fuel moisture, under which we have studied various sub factors also. Then we have also studied what are the major causes of forest fires, which, where we have studied the natural, accidental and intentional forest fire cases. And in Indian context, we have mostly accidental and incidental cases which happen in case of forest fires in India. There are very rare or approximately no cases of natural causes of forest fires. Then we have the types of forest fire that we have also studied in our previous lecture, where we have studied the surface, crown and ground fire or subsurface fire. Then we have also studied or completed the global scenario of forest fire, where many countries or they are facing the problem of forest fires, and these are the areas which are having forest fire cases. Then we have studied the Indian scenario of forest fires, okay, where we have observed that in Indian context we have approximately 99% of the total cases, they are due to the forest fires. Then we have seen that every year around 4400 million case of rupees, they are getting lost by these forest fire incidents. So these are the various facts which we have discussed in our previous class also. Then we have taken up an case study of Shimla district of Himachal Pradesh. As I have told you, that Himalayan forests, they are very prone to fire due to the existence of pine forests. So this is a case study we have, which is my own research during my PhD. So we have done a lot of research on forest fire, from where we have started from the risk zonation mapping. Then we have also done for simulation mapping. We have also gone through different modeling, use of different models like knowledge based modeling, then the EHP modeling, which is also known as multi criteria analysis, MCDM, decision making, multi criteria decision making. And then we have also opted for the fuzzy method for identifying this forest fire mapping. Okay, so we have taken up the case study of Himalayan forest fires as a case study. Okay, then after that, in this case study, what we have tried to do, we have demarcated the area, or we have taken the area as a Shimla forest district, and then it is the having seven different divisions, which are including the complete Shimla circle and the Rampur circle. From Rampur circle, only two divisions, and this is a total area. Okay, so these are the various flora and fauna and the tourist places in the Shimla district, and this the case studies in the district that we have also gone through in our previous class. Okay, then we have taken up few research questions, out of which we have already completed in our previous class these three research objectives, where we were, we were trying to go for the, forest fire risk model, whether it has got any connection with the forest type while we are creating these risk models. Then can we build uh, model where we have forest fire susceptibility and modeling in a reasonably accurate manner, or is it possible to estimate the accumulated risk? So these are few questions which we have already studied in our previous class. These are the objectives, these are the different material methods. Now I am directly going to our results of simulation modeling, because we have already completed these uh, three models in our previous study, where we have talked about the knowledge based model for calculation of forest risk, the fuzzy triangular trapezoidal method for the cumulative risk assessment, and the MCDM for the calculation of forest fire risk. Okay, where we have taken various parameter into consideration. Now we have the simulation modeling, where the forest fire growth and spread was calculated. In case of these models, where we have talked about the three models, we have calculated the risk factor, that in different forest divisions, what is the amount of risk a particular area is having. Now in the simulation modeling, what we have tried to calculate, we have tried to calculate the fire growth and spread. So with the help of this simulation modeling, we were able to calculate ki in which direction, or what rate the fire is expanding with the increasing of time in terms of their hourly distribution of time. So district Shimla was selected to create a forest fire model using simulation for spatially and temporally simulating the spread of fires under condition of heterogeneous terrain, fuel and weather conditions. So if you go through the methodology part, okay, if you go through the methodology part here, okay, so in the previous class we have discussed all these things till here, the creation of forest fire risk map based on different layers and different modeling techniques. And now we are after the calculating this fire risk, we are into the calculation of this statistical analysis of the fire simulation model. Okay, where we have taken all these layers into a as a input parameter. We have also taken this meteorological data along with the forest type and forest density, along with the topographical factors, along with the accessibility, along with this meteorological parameters. We have taken all these things into the consideration for calculating the simulation modeling of forest fire. Now, after this simulation, we have got the results as the fire area spread, day-wise expansion of the forest fire, and the forest type, whether it is a plain fire incident or whether it is a horizontal fire. Okay, so based on these two things, the area, which is the risk prone, okay, area intensity, and the spread of fire on the basis of temporal things, we have come up for the management plan. Okay, so where we were into the simulation modeling. Okay, so for Shimla district, we have done the forest fire simulation using the spatial and temporal simulating the things for calculating the spread of fires under different conditions of terrain, fuel, and weather. Okay, the forest fire simulations were calculated for the different seasons, for summers, rainy, and winters. Okay, so there are prominently three different seasons in the area. So we have tried to do or perform this simulation for three different seasons, and these seasons were summers from March to June, rainy season from July to September, and winters from October to February. So these were calculated using the parameters shown as the meteorological data. I have already discuss the complete methodology, where we have different parameters related to meteorological parameters. In meteorology, we have taken the temperature, rainfall, humidity, cloud cover, and the wind speed and direction. Then in case of topography, we have taken slope, aspect, elevation, hill shade, view shade. And then in case of fuel type and density map, we have taken the fuel type and density, both the things for the complete Shimla district. Then the time duration also taken into the consideration. We have fixed up with the 2 days or 3 days, because in hilly areas, due to the accessibility of different areas, due to the tough terrain, the accessibility of human is very less. Okay, so we have fixed up with the 3 days of maximum fire incidents. Okay, so these are the input types, where we have the landscape layers, GIS layers, which includes latitude, elevation, slope, aspect, fuel type, vegetation, and cover type. Then fuel adjustment and fuel moisture, where we have talked about the fuel moisture content. Then climatic parameters, I have already told you that wind speed, direction, relative humidity, temperature, etc. Then the ignition probability. Okay, for that we have taken the road probability map, then the percentage or the numbers of simulations also being taken into consideration. Then miscellaneous data, the burn period, the ignition point, various ignition points. One ignition point in one district we have taken as an input parameter. So these are the various input parameters which are required for the calculation of the simulation. Now in next slides we will be seeing, this is a screenshot of the parameter, the input parameters which we have taken. Okay, here you can see that we have taken a landscape files, we have taken different adjustments, moisture contents, then the different conversions, then this is the weather files, WTR. This is the wind speed and direction related files. So all are taken into the canopy characteristics. Also, you have to input, and then different vectors also you have to attach. Then burn period, where we have fixed up a period, that also you have to taken into consideration. Then we will go for the simulation model. Now these are the outputs. Now here, in case of outputs, you will see we have opt 1 point in each and every forest division. So here, these different colors are showing the spread of fire day wise. Okay, so the first day is being shown by the yellow, second day red, and the third day expansion of fire is shown by the blue color. So this is for the June to August month for the rainy season. This is the graph which is showing the time ki per hour what will be the spread of these fires and what will be the loss of fire. Okay, so this graph is showing the time, with time how much fuel will be lost. Then the intensity of fire, what will be the rate of spread, okay, and what will be the area which will be heating. So this is again the fire intensity. The area, if earlier this map was showing the spread of fire, this map is showing the intensity of fire in terms of the fuel loss, in terms of the heat from June to August for the same month. Then this is the fire area spread. Okay, how much area will be, affecting in terms of the fire area and the time. Okay, so here the x-axis will show the time and the y will be showing the area in terms of hectare. Then the perimeter of the spread, again time and the perimeter in kilometers. Then the same calculations with the same input parameters, by changing the month we have also calculated the day wise fire spread of the month March to May. Okay, so here again you can see the spread is more as compared to the previous one. Here the spread is little less, but same points, if you ignite fire or simulate fire, the with the help of different parameters, you can see in the March to May we have much fires as compared to this. This is the again fuel weight loss and the intensity of the fire for March to May month. Okay, which we have calculated with the input parameters which I have briefed you in the previous slides. Okay, so this is for the month of October to February. Here you can see again the spread is again in the form of shrinkage. Okay, so this is the graph which is showing the fuel weight loss and the intensity of the fire, which is you can see here, which is quite less. This is this parameter and the area which is being spreaded by the fire. Okay, now this is the time frame key in 1 hour. The horizon, if the fire spreads is horizontal, then it will be 7.7 kilometer of perimeter loss. If it is slopy area, then it will be 8.5 kilometers of spreading of fire. So if you see the time with the increase of hours, it will increase. So if suppose we stop it here itself, only 7 percent or 7.7 square kilometer area will be under this risk, rest we can save. Okay, so this simulation is very important. If you can manage the fires based on this simulator, in the very initial stage we can stop uh, the amount of loss which will exceed with the increase in number of hours or number of days. Okay, so based on these things, we can go for the different management strategies also. Okay, now what are these management strategies? That the fire risk model developed using geospatial parameters, used in developing the fire risk model, moderate to very high risk prone areas required to give top priority in taking the timely management and decision making action to prevent the occurrence of the fire incident in the area. So what we can say, whatever area is falling under the very high to high risk prone areas, they need to take a special attention as far as different management related programs are concerned. Okay, so whatever model we are using for calculating these forest fire risk using different geospatial approach, whatever area is falling under moderate or high risk to very high risk prone zone, so we can set up a priority that these are the areas which are having very high and high risk. We need to go for the management strategy at the earliest. Whatever area is moderate to high, we can go for the second top priority on those areas. But whatever areas are low or below moderate, we can go little bit leniently, but that doesn't mean that we can ignore those areas. Okay, because in hilly areas everywhere there are tourists, or they are the routes which connects to different tourist areas. And during summers, due to the dry conditions of the forest, due to the existence of pine trees, okay, due to the loss of humidity into the forested areas, and rush of different tourist activities, okay, they lead to sometime even in the moderate or low risk areas, also under the threat of these fire incidents. Okay, so that doesn't, if some area is having low or moderate risk, we cannot ignore that area. But yes, at the priority level we need to focus on the high, very high and moderate risk areas. Okay, but we need to take care the low and no risk areas also, as far as the forest fire incidents are the concerned. So we can go for different kinds of management strategies, where we can make the boards denoting that these are the areas which are having different kinds of forest fire risks. We can also educate the people in the different areas, hilly areas, that they have to be very careful while different kinds of tourists they are hitting into those areas. They also need to keep an eye on those forested areas. Along with that, the forest officials, they have to be vigilant in those areas. Okay, so different securities, different things can be managed to manage this kind of forest fires. Then the recommendations and the requirement at the implementations, also required are the fire records can be maintained time to time. Okay, different preventive measures can be taken for the different kinds of preventive measures which can be taken for the controlling of these fires. Okay, then we can also go for the public awareness and educating programs for local people, so that they can be trained that if there are high temperatures and dryness in the the different time periods, then they have to be aware of throwing or using different kind of smoking activities, or burning of forest or campfires or sort of things. So we have to educate the people over there in the different forested areas. Then we have to have a quick detection techniques. We can also go for different forest fire fighting equipments available in the different compartment levels, so that if such kind of things happen, those equipments can be readily available within the different forested areas, or different forest management peoples or organizations, so that they can deal with the situations. Okay, then we can also go for the modern fire control equipments like Pulaski, brush hook, Melod, fire beater, fire hook, double bit X, fire rakes, shovel, helmets, then backpack pumps, field boots or jungle shoes, you can say, then torches. If the fire incidents took place in different times, they should be available with the torches to go to the different forested areas. Water bottles, haversack, protective clothes, forest aid kits, and fire blanket, fireflies. So these all are things which we could able to manage with the different forest fire plan, which at the various division level, various people they are having it. Then the fire fighting equipments, they should be available with the different fire fighting equipments, like at least 10 drums of water of 200 liters capacity in each compartment, at least 25 knapsack sprayers, then 10 fire extinguishers, 10x axes, 10 bit hooks, and then 10 sickles. A medium sized truck for quick transporting the squad. So these things should be readily available in all the fire prone areas. Then the communications, wireless network and telecommunication is all the time should be available during different forest fire seasons. Implementation of geospatial technologies, and other than that, it should have surface communication available always. Okay, then the implementation of geospatial technologies. Now, as you have all studied that different geospatial techniques and simulation techniques have been an overview about the aerial spread of the fires, its intensity, and the rate of combustion day wise, even on the hourly basis. So, as this case study, this is using different geospatial techniques for demarcating the risk prone areas of fire, and along with that, the different simulation techniques. I told you in the previous class also that in simulation we are artificially generating all the phenomena which are actually needed for forest fire to happen. Okay, so with simulation techniques, it gives us an overview about the aerial spread, that how much area can be affected, and what will be the intensity of the fire, what will be the rate of combustion as far as the days, number of days are concerned, and even the early spread of the fire is related. So with this, we can go for the different implementation of different management strategies. How? Because we know that if these are the areas which are having very high or moderate risk of fires, and this will be the intensity in terms of the aerial spread, in terms of their temporal spread, based on every hours. So if we have managed the fire at the very beginning stage, we could able to manage so much of loss. Okay, so that's how we can say that implementation of these geospatial technologies can lead to a very helpful role as far as the forest managements are concerned for different forest fire managers and organizations. So if the fire managers have an overall idea about the forest fire risk zones, and these areas can be put on top priority to be managed, even the area with the moderate risk can also be taken care. That's what I have told you, that if the managers have the proper records of these kind of activities, then yes, we can they can easily go for the areas which are having high risk on top priority, and not even ignoring those areas which are having moderate risk. So everything can be taken care, having all the facts into their mind, that these are the areas having different intensities of fire risk and different spread in different areas. Okay, so based on that, we can go for different strategies for the planning. So these techniques are helpful in taking timely and quick actions against forest fire risks. Okay, so these are the different activities which are really very helpful in different kinds of management strategies in timely manners. The information generated in this study. So through this case study, what we can say, that the information which this paper or this study is trying to give is immense use of link to the management and policy making strategies such as forest management, land use planning, and sustainable management of the natural forests or natural resources. So with this study, we can go for the different kinds of management strategies and their policy making level planning, such as forest management, land use planning within the forested areas, and yes, of course, the sustainable management of different forest resources. Okay, then emergency management can play important role in prevention and control and management of different disasters in quick manner. So like, with this kind of studies, different officials, different people who are residing into those areas can be trained, so that timely prevention, control, and management of these disasters can be taken care with quick time period. Then having this study or case study, after performing this case study, we could able to get different conclusions, that we have used different studies using different models, where we have used knowledge based approach. Okay, from which we are able to calculate under low and no risk zone around 31.62 percent and 30.85% of total area, whereas moderate to high risk areas under 38%. So which is quite high, and we need to take care all the areas, whether they are having high risk, moderate risk, or low risk. Okay, So using AHP, we could only get around 12.73 and 4.5 under moderate and low risk zone area, whereas 4.65 and 2.21 is under high and very high risk zone. Okay. Lastly, in case of fuzzy triangular, we got around 6% and 1.69 area under high and very high risk prone area, whereas around 34 percent, 45 and 12% under no risk, low risk or moderate risk zone were found. Okay. And after going for the quantification of these all three methods, we have concluded that all the methods have given almost accurate results. But if you compare those results with the actual reality, then the knowledge based method is found to be a very good result as we compare with the AHP and fuzzy. Okay, if you go for the comparative study, then some fire cases were also to be in the areas of higher risk zone, and high risk zone are very few cases with no fire incident were recorded in low risk or no risk zones took place in 2001 to 11. So these are the conclusions. As I have told you in the in initial level, so we have got around six publication at that time when we have completed the studies. I mean, I have submitted my PhD in 2011. So till that time, we have only five papers related to these forest fires. But now we have two books under forest fire, and then we have a few more districts which we have covered in terms of their meteorological expansion, in terms of the socio-economic vulnerability assessment. We have also completed those case studies. Also, I'm going to tell you in my next maybe lectures. Or after that, we have also gone through with the studies like the impact of these fires on different tourism activities, because if there are cases of these kind of forest fires into the areas where we have different kinds of forest fire related activities, so maybe the tourists, they can maybe terrified. So we have to control these kind of things, and what is the impact of these tourism these fires on tourism activities, these kind of study which we have also performed. Now my students, they are also working on few more districts like Bilaspur district of Himachal Pradesh, then Nahan Sirmaur district. One more student, PhD scholar, he is also working on that. And few parts of Uttarakhand we are also working, where my students are working. So we have a very good amount of work in this field. So these are few surveys during my PhD, where we have calculated the tree height. You can see through this hypsometer, we are trying to find out the tree heights in different areas. Then we have also taken some sample plots in the forested areas. These are few forest officials with me who helped me during that time. And then this is with connected with the diameter calculation of the tree. And then we have also taken up few GPS points. Okay. So these kind of studies also require this field verification, pre and post both. So with this, I think I have tried to tell you little bit about the different forest fire activities in my through my case studies. And now I would like to brief about one more study where we have taken up the tourism point of view. of the area. Okay, so there what we have done, we have taken up the two type of tourism is there in Shimla district. So there we have tried to calculate first the different tourism activities in terms of their adventure is concerned, in terms of their scenic beauty is concerned. So we have calculated these two types of tourism activities in the Shimla district, and then we have tried to correlate these studies with the uh, fire incidents of Shimla district. And then we have tried to correlate that how these activities are impacting on the different kinds of tourism activities. One more study is there, which one of my student has performed. In that study, what we have done, we have taken these topographical parameters, which I have told you in my slide, that we have taken slope, aspect, elevation. Then we have also incorporated the census data, where we have included the male, female, and child population, and then we have tried to incorporate the meteorological parameters also. And then based on all these parameters, we have also tried to get the vulnerability analysis, where how these different age groups are affecting with these forest fire related activities. That thing we have tried to calculate. Then we have also gone through a comparative analysis of these models, where we have gone through these three models, where knowledge base and what do you call this, MCDM and fuzzy logic were taken into consideration. And we have tried to calculate the different values of different layers. And then we try to quantify all the maps with the actual fire incidents of different forest divisions. We have plotted those forest points or forest fire points of last 10 years onto the map, and then we found that the knowledge based map is giving us more accurate result in as far as the intensity of fire is concerned, as far as the risk of the fire is concerned, because many of the points of last 10 years fire incidents were exactly plotting over the knowledge base. So that's the base on which we were able to decide that the knowledge base model was properly suited for the model which we have used for knowledge based model. Okay, so that paper was published in disaster prevention and risk assessment in the Emerald publication house. And then we have also worked on this Nahan or Sirmaur area. My one PhD scholar, he is working on that area, and he is working on the socio-economic parameters of the fire incident into those areas. One of my student, he has worked on the one area of Jammu Kashmir, Bhadarwa, I think. And then he has tried to use the modest data, as in modest data we can go for different kinds of temperature related analysis. So based on that, he could able to get the results, where we have information based on the temperature, which are the areas which are having more risk in terms of the fire incidents. So we have tried to worked on many areas of Himalayas as far as these forest fires are concerned. So, with this, I would like to end my talk. If you have any queries, you can drop me in my chat box, or you can mail me, or you can ask me here also. So with this, I am ending my today's talk, and tomorrow we will be meeting with some new topics of forest management or forest damage related topic. Okay, thank you very much.